Welcome to this video tutorial on how to start a program from scratch and create an automatic alignment. And this alignment is going to be created to the top surface, the right plane, and the front plane. So we'll come over here to File and New. And this really isn't required for this, but I'm doing it just for the sake of the video. I'm going to go CAD file and load, and this is really just to allow you to have a better visual of what I'm clicking on. So I imported the CAD model, and notice that the origin comes in at the location that I mentioned here. We want to touch off to the top, the right side, and then the front, and that will put our origin right here. Now on the CMM tab, CMM settings, the stylus are already defined. On the measurement tab, base alignment is yellow. So we'll start here. We'll click on the base alignment. I'll accept all the defaults and say OK. And I'm just going to leave this base alignment dialog open, and it will be populated as we click on different things. Now also, if I look over in my Features tab during this process, you'll see I'll be adding features in the background. However, it won't be immediately obvious because we'll be looking at this window here. All right, so right now, in the real world, I'm going to unlock the joysticks. I'm going to turn the speed dial all the way up, and I'll come over and touch 3 points on the top of the part. So to show you where these 3 points are and a way you can see better, I'll show you on the CAD model. I'll touch point number 1 here, point number 2 over here, and point number 3 will be right here. So I'm deliberately driving into the part, and then I lift up, move to the next coordinate, drive into the part, lift up. Notice in the Features tab, this opened up automatically when I touch my first point. After 1 point, it recognized a point. After 2 points, it's recognizing 2D line 1. And if I come over and touch my third point, it changes to plane 1. Now at this point, you have to remember to hit OK here. The most common mistake is moving on to the next step of the process without hitting OK. So notice that that populated the spatial rotation and it populated the Z origin. It may also modify the axis depending on what you touched. Next thing we're going to touch is one line on the right side of the plane here, and we're going to touch a point here and a point here. Now that will automatically set our planar rotation to Y. Notice it's at plus X right now. It will change to plus Y when we're done with that. So in the real world, we're coming over and touching off point number 1. Notice that that gives us a Features dialog box pops up, and it gives us point number 1. When we drive in and touch the second point, the Features window now says 2D line 1, which is what we want. We say OK, and notice that it has now populated planar rotation. It automatically set this to plus Y, and it populated our X origin. All right, so now we'll come over and touch 1 point on the front of the part, and we're going to touch that point right about here. So we'll drive in and touch that point. The Features window opens up automatically, grabs point 1, we say OK, and point 1 has been populated in the Y origin. We'll say OK, and now we are good to go. Now at this point, the CAD model is actually in the wrong position. And I brought this in just for the sake of the video to show you the points that I'm touching. And it's kind of hard to see in this small window down here what I'm actually touching. What I want to show you is that this actually created a coordinate system in the real machine's travel, whereas I imported this model at the machine's origin. If I wanted to correct the position of the model at this point, I'd have to go CAD, View, and Delete, and then CAD file, and load. I'd have to click on cadcube.sat and re-import it. And notice that CAD models do come in wherever the origin of the CAD model is. So the reason I selected this alignment, the top plane, the right side, and the front, is because I knew that that matched the origin that was already in the CAD file. Now at this point, if I want to do clearance plane, I have two options. I can do my clearance plane manually. If I want to do it manually, I will unlock the joysticks and move over so that I am, about 100 thousandths, maybe a half inch above the part, and I'll press the little missile fire button on the right joystick, and that will automatically populate this plus Z right here. It automatically advances the yellow highlight to X plus. At this point, I am now moving the probe, so that way the probe is just off the right side of the part. Yeah, maybe 100 thousandths to a half inch or so. I'll press that joystick button again. Now it advances to plus Y. I'll move to the back of the part, so now the probe is over here somewhere. Press the missile fire button again. Notice that the size of our clearance box is starting to show in the preview here. Now we'll go to X minus, so we'll move off the left side of the part. Right now I have the probe somewhere around here. Press the missile fire button. And then lastly, we have minus Y, so I'll move just off the front of the part. Now the probe is right about here. I'll press the button one more time, and we actually do not do minus Z. I know this looks a little bit weird, but we don't do minus Z. The software does not use it anyway. We'll say OK. For this question pop-up, where it asks you, do you want to update clearance plane for defined features, you will always say no. Okay. Now, because that's how you set the clearance plane when you're doing it manually, I do happen to have a CAD model in here. So an alternative approach is you can click on Define Clearance Plane and click Clearance Plane from CAD Model. You select what you want your offset to be. 393.7 is the default. It's converted from a metric value. I usually just accept that and say OK and OK. And again, to this pop-up dialog, I say no. So the first approach I showed you is if you do not have a CAD model. The second approach I showed you is if you have the luxury of a CAD model. Of course, having a CAD model is always easier. So we've set up our measurement tab. We're all green here. This one down here for temperature compensation will always be yellow. So as long as you have greens up top, you're good to go. We'll worry about characteristics later. And notice in the Features tab, we have our plane, our 2D line, and our point. Over on our stoplight window here, let's verify that we've set up our coordinate system correctly. We want to make sure this is set to base alignment. We will manually move the probe over to the approximate origin. So I'm moving the probe right about to here, and I see that the X, Y, and Z are close to 0. I'll move positive in the X-axis. I see the orientation is correct, and the X-axis is moving here. And then I'll move positive in the Y-axis, and I see that the correct axis is moving, and it's positive here. All right, so the last move is let's go verify that we have set up this coordinate system correctly by running the program. In the Features tab, we will click on the top, hold Shift, click on the bottom, we'll hit Run, and because we have not set this yet, we want to pay close attention to this. We want to clear existing results. For our alignment here, we'll select Manual Alignment. We'll do Current Selection. And then we'll come over to the CMM dropdown here. We want Features List, Clearance Plane, Slow Through First Feature, and if we don't have 55 in this box, we'll highlight whatever's there and we'll type 55 and press Enter. We'll slow the speed dial all the way down and hit Start. For more details on what happens next, you can refer to the manual alignment tutorials, as I want to keep this video short. Thank you for watching, and I'll see you at the next one.